Hello, welcome to the GATE Academy e-lecture series. Today we will be covering the topic of theory of machines. This is the first lecture in this series, which is introduction. The subject of theory of machines is quite important in mechanical engineering, which covers the area of machines and mechanisms. A thorough understanding of fundamentals of this subject is very important throughout your career as a mechanical engineer to design and analyze machine components. Particularly from the point of view of GATE, if you see the breakup of questions appearing in GATE over a period of last 4 or 5 years, you will see that roughly 8 to 10% of questions in GATE are asked from the subject of theory of machines. Not just by getting limited by the GATE examination. If you just see the subject as a whole, it is a very interesting subject, as you are aware that we are all surrounded by machines and we can see its application in our day-to-day lives. So we will try to get a high-level definition of a machine first, and later on I'll let you through the syllabus of the GATE examination and the details of the topics that we are going to cover in this subject. So if you see the definition of the machine, a very high level definition says that machine is a tool or device that is intended and made, organized to achieve a particular goal. So this high level definition encompasses all the machines that we see around us, may it be mechanical, chemical, electrical, electronics, all of this. But if you limit yourself to the mechanical engineering subject, then the machines are defined as mechanical devices which are used to accomplish work. So, as you know from your basic understanding of physics, that work is basically derived from force and displacement. So in a similar fashion, we can also break down the definition of machines as follows. The machines can be intended to transmit motion, that is displacement, from one form to another. They can be used to transmit forces from one form to another, and also it can be doing a combination of both. So the combination of force and motion is power. So it can be used to transmit power from a source to a target in a desired fashion. So how are the machines formed? If you see at the heart of the machine, like there are various building blocks that are called mechanisms, which form the basic building block of a machine. So a machine can be a very simple machine like a stapler or a lever or a screw arrangement, nut bolt. It can be a very simple machine, or it can be a very complex machine also, like a printing press, sieving machine, industrial manufacture line, automated robotic lines, gym equipment, presses, earth movers. Like there can be various complicated machines also. But if you see at the heart of all the machines, you'll find mechanisms, and various mechanisms are joined together in a particular fashion to achieve a particular force or motion transmission. So I'll just list out a few examples of mechanisms just to help you to visualize those better. Like you can visualize a lever about a fulcrum. You can see here that here it is used to transmit force 1 to force 2 in a different fashion. So you can apply a lower amount of force here on the longer fulcrum, and you can get higher amount of force here. So this is used to transmit forces. Another example is slider crank mechanism. This you can see in internal combustion engines. So in this mechanism, a rotary motion is converted into a linear motion. So here you see the transmission of or transformation of motion, and here you can see transmission of force. Then you have gears. The gears are used to transfer a higher angular velocity to lower angular velocity, as you may be aware. So it is a kind of motion transmission. Then we have cams. So in cam, a rotary motion of the cam is converted into linear motion. So like this, and you also have the screw nut arrangement, which is used to transmit the rotary motion of the screw into linear motion of the nut or vice versa. So the examples outlined here are just for illustration purposes, and there are, if you look at the subject, is quite vast, and there are many form of combination of these mechanisms which are used to form a machine. Although the subject of theory of machine is quite vast, we have to define a framework or syllabus that we will cover in this lecture series. So I'll now outline the syllabus for the subject of theory of machines. So I'll just list down the topics which are required to be covered from the perspective of GATE examination and also as a bachelor's course in mechanical engineering. But before doing that, I would like to take you through a typical example of machine. So by taking you through the example, I'll show you why we need to do analysis of various aspects of machining. So we'll list down what aspects of machines are really required to be analyzed as a mechanical engineer. So we will take here example of a very well-known machine, that is car. So all of you are familiar with this example. Here, if you see as a machine, what is the basic purpose of this machine? It is to convert chemical energy in gasoline or diesel or petrol to mechanical energy and imparting motion. So if you look at the heart of this machine, you'll find an internal combustion engine. This is the liner of the combustion engine. This is a piston, and you are having a crank shaft mechanism. So here, by combustion of gases like petrol or diesel in gaseous state, you get the expansion energy, which is converted into linear motion of the piston. The linear motion of the piston is converted into rotary motion of the crankshaft by this slider crank mechanism. This rotary motion is transmitted with the help of gears, or in some cases chain sprockets, like you can see in bike. This motion is transmitted from the crankshaft to the wheel, and from the wheel, the rotary motion of the wheel is transmitted by this friction between the wheel and the land to linear motion of the car. So here, as you can see, there is transmission of forces and motions from one form to another throughout the cycle. So chemical energy into gas, thermal energy to linear motion or force on the piston, that in a circular manner, in a circular motion, the circular motion getting transmitted to the wheels, and that circular motion again getting converted to a linear motion of the car. However, if you look at various stages in this machine, the forces and velocities involved in initial stages, like maybe one here at the piston, are quite different from what we observe at the final output of that is the linear motion of the. So this transmission of motion and forces is accomplished with the help of mechanisms. So you can see various mechanisms in action here in this machine. So the first topic that need to be covered subject of theory of machines is the mechanisms. So I've already explained you about the mechanisms that are the heart of the machine, which allows all the motion and the forces transmission. So in the GATE syllabus, in this lecture series, we will understand formation of mechanisms, how various links and joints are joined together, how various components are joined together to form a mechanism. This we will analyze. And later on, these mechanisms as a basic building block can be assembled together to make a final machine. So we will not be considering real machines assembly. We will be only focusing on mechanisms, and then it is quite straightforward to later on form an assembly of mechanism to get the final working machine. So here we will understand the basic principle of mechanism formation. We will analyze velocity of various components in a mechanism, acceleration of various components. Acceleration is important for dynamic analysis are subjected to loads, and this dynamic analysis will also include transmission of forces. This will be covered in the present lecture series. We will be taking up few typical examples such as gear train, slider crank mechanism, etc. So the principle of mechanisms will be better illustrated with the help of these examples. The second topic in the theory of machine is the subject of vibrations. The vibrations are also quite important along with the mechanism formation in machines. The basic building block in a machine are mechanisms. They are supposed to be rigid components or rigid links which are joined together by joints and move in a predetermined fashion. However, the vibrations do not consider the components to be rigid. So, it studies the internal motion of a component in a machine. It is quite important to understand vibration, to understand resonance of various components, because resonance can sometimes lead to very high stresses in a component and may lead to its failure. Also, the vibrations are quite important to be studied from the perspective of human comfort, both in terms of mechanical vibrations and acoustics. So you can just visualize the car example. If there are too much of vibrations in a car due to the noise from the engine or maybe some transmission gear, clutch, then it will not be a comfortable car, and that will be very detrimental in machine design. You may be aware that the noise is also considered as a form of pollution, and there are various government regulations regulating the amount of noise emitted from a particular machine. So the machine designer has to comply with those regulations. So the subject of vibration is important first to understand the stresses in a component, the dynamic stresses which can lead to component failure, and second to meet the human comfort requirements. So if you see the syllabus of the subject of vibrations, we will be covering free and forced oscillations, of a single degree of freedom. So these are basically simple harmonic oscillation of a single body, single degree of freedom, and they may be free or forced. Free means natural vibration of a system. Just you have to uh, move it away from its equilibrium state like a simple pendulum, and then it will keep oscillating about its mean position. It is something similar to striking a tuning fork. When you strike a tuning fork with a hammer, it will, with an impact, it will keep on resonating what's its mean position. So these are free oscillation. In a forced oscillation, you have a driving source which is continuously moving the object. So you have a tendency of the object to move in some direction. You have a vibrating source which is causing resonance in the object. So we will be letting you know about in detail of these aspects as we move along the course. We will be studying damping of oscillations, then vibration isolation, resonance, critical speed of shafts, so the critical speed of shaft is one typical example of resonance. There are many examples, but we will be covering those examples while we are studying free force vibration, damping, and isolation. And one other typical example is critical speed of shafts. So the details of this syllabus we will dig down further deep. What are the various topics that are need to be covered when we move to the actual vibrations lecture. But here for now, I just want you to be aware that the subject of theory of mechanism is having two components. First is the mechanism, and second is the vibrations. So now we will go ahead first with the subject of mechanism.